So in this particular lesson, we're going to be talking about trig values of special angles. It's going to be important that you guys have a drawing of the unit circle. Dealing with this, it says find the following trigonometric values, express your answers exactly. So we're not going to be doing approximate values, we're going to be doing exact values. So here in the unit circle, basically here's the formula for a circle, x squared plus y squared equals 1. And you'll notice if I go around the circle, if I start at 0 degrees and I start going my way around the circle, let's look at 30 degrees. Okay, so I'm going to take a stop right there. Let's take a look at this. Excuse me. What this is saying is this angle right here, theta, is 30 degrees. Now, one of the special right triangles is a 30, 60, 90. So I'm going to put 30, 60, 90. And if you remember those from geometry, the ratios, I'll make a little chart here. Probably did this when you were in geometry. 30, 60, 90. I'm using a new drawing board here. It's very sensitive. I got to be careful. There we go. So, for example, if I say the shortest side is 1, the side opposite 6 degrees is going to be 1 radical 3, and then the 90 or the hypotenuse is going to be a 2. So, if we were to figure out these ordered pairs for x and y, you can clearly see that this distance right here is across from the 60 degree angle, so that's radical 3, that's 1, and that's 2. All right, so in a 30, 60, 90, you have a 1, the hypotenuse is 2, and then you have radical 3 as the 60 degrees. Now, in the unit circle, we need to understand that the radius here is actually equal to 1. So this triangle, we need to kind of reconfigure. So let's take half of everything. All right, so if we take half of 1, that's just going to be what? 1 over 2. If we take half of this, it's going to be radical 3 over 2. If we take half of this, it's going to be a 1. So these ratios would also work for a 30, 60, 90. So if we take this right here and I erase that, and I erase that, and I erase that, we could say this side is radical 3 over 2. This side is a half, and this side is a 1. So we have so right now in a unit circle, when you have the radius, that's your r squared. The cosine of theta is x. So what is our cosine of theta? Our cosine of theta, what's that distance from here to here? That's radical 3 over 2. And our y value is this distance right here. That's going to be 1/2. So if we wanted to check it, all right, we could go over here. And we got to find my calculator. Where's my calculator? 1 second. There we go. All right, go to mode, make sure I'm in degree mode here. So if I say, what is the cosine of 30? You get that 0.866. Well, that's the same as saying radical 3 divided by 2. If I said, what is the sine of 30? You get a half. So, what does that mean for us? Well, what I want you to understand, if you understand the unit circle and you understand what 45, 45, 90, and 30, 60, 90s are, then you can get those special triangles. Let me go to the 45 and show you a 45 real quick. There we go. Right there. Now, in a 45, 45, 90 triangle, all right, a lot of times you would see these sides are going to be the same across the 45 degrees. So the two special right triangles that you need to know are the 45, 45, 90 and the 30, 60, 90. So I'm going to put 1, 1, and let's put radical 2. All right. But what if the radius was a 1? All right. Well, in order to get this to a 1, I'd have to divide everything by a radical 2. And these end up becoming radical 2 over 2. So we know our x-coordinate is radical 2 over 2, and our y-coordinate is radical 2 over 2. Now, if you're wondering how did I rationalize this, here's a quick little way of rationalizing your denominator. You always multiply it by whatever's in the denominator here. So a radical 2 times a radical 2 just becomes 2, and 1 times radical 2 is 2. So that's a way to rationalize the denominator. So this will work all the way around. So when the Khan Academy asks you for what is the cosine of 150 and what's the sine of 150, automatically what I think about is I think about the unit circle. So I just, in my mind, thinking of the unit circle, draw one real quick. All right, so if this is my initial side, 150 degrees puts me right about there, and I have a 30, 60, 90 triangle, because from here to here is 150 degrees, which means this is supplementary, that's 30 degrees. So if I have a 30, 60, 90, and I am right here, and I want to know the cosine of 150 and the sine of 150, basically all I'm looking for is the x and the y. So I'm looking for the cosine of 150, and the y value, that's the sine of 150. All right, so let's think about this. If I'm in a 30, 60, 90, and I go right here, that's going to be negative radical 3. Going up is going to be a positive 1, and that's a 2. So the cosine is the adjacent over the hypotenuse. So it's going to be negative radical 3 over 2. The sine is the opposite over the hypotenuse. That's going to be 1 over 2. And that's what I'm going to have to type in. But if you actually have in your journal your unit circle that I asked you to draw, look at that. Right here. 150. Negative radical 3 over 2, 1 over 2. Those are the exact answers. So if you have this in your journal, it makes it a lot easier to convert. So right now, all I'm going to do for the cosine, I'm going to type in a negative. Oh, not that. Delete that. Why is that not clicking? There we go. Radical 3 over 2. And 1 over 2. Okay, so now we're looking at radians. All right, so we're at what, 2 pi over 3 and sine of 2 pi over 3. So how could I convert this to degrees if I wanted to? I could take 2 pi over 3 and multiply it by 180 over pi. These pi's would cancel out. 3 goes into 180. Total of 60 times. 2 times 60 is 120. So this is the same as saying, what is the cosine of 120 degrees, and what's the sine of 120 degrees? So where would that put us on the unit circle? Put us right, let's see here, right here. Okay, so you could also, if you had your radians, look. See that 2 pi over 3? 2 pi over 3 is the same as 120 degrees. And there's your cosine, there's your sine. So your cosine's negative 1/2, and your sine is radical 3 over 2. So your cosine was, don't know why it's doing that, negative 1/2. And this was positive. Radical 3 over 2. Okay, let's try it one more time. So once again, we're in radians, all right? So if you were doing this by hand and you wanted to figure out how to do it, I'm just going to do one more by hand, and then you can, if you have your unit circle in your journal, it'll make it a lot easier to do this. So if I didn't have everything memorized, okay, or I didn't have it in my journal, here's what you would do. You would take 3 pi over 4. You would multiply it by 180 over pi. All right. Now what happens when you do this? You're converting it to degrees. These pi's cancel out, and 4 goes into 180 45 times. And 3 times 145 is 135 degrees. All right. So if you wanted to do this by hand, this is how you would do it. Build your unit circle. You'd start here at 0 degrees, and you travel 135 degrees, which puts you right about there. Now this creates a 45, 45, 90, but we happen to be in what's called the second quadrant. So this would be, remember these sides are going to be the same. This is 45 degrees. This is 45 degrees. We went 135 degrees from the initial side right here. Excuse me. So, what is the x and the y? What is the cosine of 135? And what is the sine of 135 degrees? Well, you can clearly see that this goes in a negative and that goes in a positive. Okay? So if I said this is a 1 and this is a 1, all right, this would be 1 radical 2. But we already remember that if I decided to do the cosine, which is 1 over radical 2, that becomes radical 2 over 2. So the cosine is going to be negative radical 2 over 2. And the sine is going to be a positive radical 2 over 2. And that's what I'm going to put right here. Negative radical 2 over 2 and positive radical 2 over 2. Now, like I said, take a look right here. 3 pi over 4. There it is. Negative radical 2 over 2. Positive radical 2 over 2. It's not working very well. Negative radical 2 over 2 and positive radical 2 over 2. All right. Cosine 330, sine 330. We're dealing with the fourth quadrant right here. So if we started here, 330 degrees, we go all the way around or right about there. Makes us another 30, 60, 90 triangle. There's the 30, there's the 60, there's the 90. This went 330 degrees. We can clearly see that the x value is going to be positive, but the y value is going to be negative. The sine the cosine of 330 is the x. The sine of 330 will be the y coordinate. So I like to use just the basic numbers. I'm going to say that's going to be -1, that's going to be radical 3, and that's going to be 2. So if I wanted to say what is the cosine, it's going to be negative positive radical 3 over 2. And what will the sine be? The sine will be -1 over 2. And that'll be the x value and the y value. Just remember, when I'm doing the sine SOHCAHTOA, apologize for my handwriting. This board is just not as nice as the one I have at work. I'm just doing this at home. Alright, so there's SOHCAHTOA. Understand sine is always the opposite over the hypotenuse, cosine is always the adjacent over the hypotenuse. But like I said, it's a lot easier if you just have your journal and you just look at 330 degrees, which is right there. You can clearly see it's radical 3 over 2 and -1/2, just like I had right there, radical 3 over 2 and -1/2, except that's a heck of a lot neater. So right here, like radical 3 over 2, and I'll put a minus, -1/2. So just remember, have this in your journal. And in fact, if you're watching the video, just pause it right now and write that down in your journal. Over here, there's everything in radians. Pause that, write those down in your journal, and it makes your life a heck of a lot easier when you're trying to find the exact measurements. Okay? How would you do that? Look at this, 5 pi over 3, just go to 5 pi over 3 right here. It's 1/2 a negative radical 3 over 2. Negative radical 3 over 2. Oh, not 3. 2. Just, there's 5 pi over 3. 1/2 negative radical 3 over 2. That's as easy as it gets. Alright, so good luck. I hope this was helpful on demonstrating how to do it by hand, but also, if you have this in your journal, how you can use your journal to help you.